Good morning, dear students. Today I'm going to discuss a problem on centrifugal pump. Here you can see the internal and external diameter of the pump is given as 200 mm and 400 mm respectively, whereas it is running at 1000 rpm. The discharge through pump is 0.04 meter cube per second, and velocity of flow is constant and equal to 2 meter per second. The diameter of suction and delivery pipes are given as 150 mm and 100 mm respectively. Suction and delivery heads are given as 6 meter and 30 meter absolute of water respectively. When angle is as 45 degree, power required to drive the pump is again given as 16.186 kilowatt. Then we have to determine the vane angle of the impeller at inlet, overall efficiency and manometric efficiency of the pump. So first of all, the given data are here from the question. Very easily you can note it down. Now draw the velocity triangle for the centrifugal pump. As you can see here, this one is simplified velocity triangle where u1 and u2 are drawn in a same direction, whereas in actual cases already you know that u1 and u2 must be drawn along the tangent to the wheel. So for simplicity, simply we have drawn here like this. As d1 is known to us, n is known to us, so we can calculate here u1 is nothing but pi dn by 60, so we have calculated it. And see, at the inlet we have the velocity of flow constant, that is 2 meter per second, is known to us. u1 we have calculated here, so we can get the value theta here, because as we know centrifugal pump is nothing but a radial outward flow pump. So in case of radial outward flow, v1 must be perpendicular to u1, or in a better way we can say that beta alpha is 90 degree. So here this one angle alpha is 90 degree, or vw1 must be equal to 0, that is wheel component is at inlet is 0. So we have calculated here the value of theta. Now we can see general layout of centrifugal pump here. Here's the centrifugal pump. Here the suction gauge installed here. The gauge in delivery side is installed here. This one is suction pipe. This one is delivery pipe. Now see here overall efficiency of the pump. Simply we can write here as rho QGH divided by shaft power, and rho QGH divided by 1000 is written here because the power is taken in kilowatt. So 1000 is written here. So overall efficiency can be calculated as 0.024 into HM. Now come to manometric head. Manometric head is nothing but the runner head, or runner head. How we can calculate runner head? This one is the what input here. So whatever the power we are supplying here, so total head we are getting here. Now if we take difference of total head from outlet and to inlet, then that will give us the runner head. So we have to simply take difference of total head at outlet and total head at inlet. That's why it is written here as v naught by rho g plus v naught square by 2g plus z naught minus pi by rho g plus vi square by 2g plus zi. As we know, the velocity at in delivery pipe and velocity in suction pipe, that simply we can calculate. As we know, we already have the discharge here, so value of discharge, so velocity in delivery pipe is nothing but discharge by area of cross section of pipe, that is pi by 4 d square. So from there we can get the value of velocity in delivery pipe, whereas in velocity in suction pipe similarly we can get by q by pi by 4 ds square. So we have got this one. As nothing has been given about ZO and ZI, so we will consider that ZO minus ZI is negligible, or we can say both of the gauges are installed at the same level. So this has been taken as 0. So simply putting these values, we can get the value here. Yeah, one more thing, pressure in at outlet and pressure at inlet is given to us as, here you can see, 6 meter and 30 meter absolute, in terms of given here absolute of water. So head is given in water, so simply we have to note it down here, and we have calculated these values here. Now next one is manometric efficiency. Manometric efficiency, so d1 is, we have d1 and d2 known to us, so we can get the value of u2. And now see here at the velocity triangle at outlet, u2 is known to us, phi already given here as 45 degree, and vf2, that is velocity of flow, again that one is given here, velocity of flow is constant, that is 2 meter per second. So vf2 is known to us. So 1, 2 and 3, all these three parameters are known to us, so we can say the triangle is completely defined. So we can apply here in the outlet triangle, simply calculate tan theta equal to vf2 by u2 minus vw2. That is, from here you can see tan phi is nothing but vf2 divided by this one value, and this one is nothing but u2 minus vw2. So we can get from here. Then vw2 we can calculate, because vw2 is only unknown in this equation. So vw2 we have got as 18.94 meter per second. Once you got vw2, manometric efficiency is nothing but manometric head raised to the runner head, and manometric head to the runner head is nothing but hm divided by vw2u2 divided by g. That is, in simplified form we can write simply as ghm divided by vw2u2. Putting all these values, we can get the maximum, the manometric efficiency as 16.98. Thank you.